Welcome everyone to day 3 of Unit 8. We should have our unit packets out. We're going to do this warm-up together, so have your warm-up sheet out as well. And we're going to need our new reasons card that we have for this unit as well. So you can be taking those 3 things out. Homework for tonight will be page 15 and 16, and we're going to be looking at proofs that use parallel lines today. Now, we worked with parallel lines back in an earlier unit this year, and I have on here our basic parallel line picture that we saw. The 2 main parallel line angle pairs that we're going to work with in proofs are alternate interior angles. So those are ones like 3 and 6, and we often identified them by a zigzag. So one way we know 3 and 6 are alternate interior is because when you do a zigzag involving the parallel lines, they're the angles of the zigzag. We also could have done our zigzag going that way, and then the angles of the zigzag are 4 and 5. So those are both considered alternate interior angle pairs. Now, the other one that we'll work with in this unit are corresponding angle pairs. And if you think of each intersection as having a top left, a top right, a bottom right, and a bottom left, the corresponding pairs are the ones that are in the same spots. So for example, 1 and 5 are both in the top left. 2 and 6 are both in the top right. 4 and 8 are both in the bottom right, and 3 and 7 are both in the bottom left. So those are our different corresponding pairs. Now, we talked about in the earlier unit when you had this basic picture that any two that were either both acute or both obtuse, they were equal to each other, which now without actual measures we would say congruent. And if it's one acute and one obtuse, they were supplementary. So if we look at 3 and 6, those both look acute. So those should be the same. And 4 and 5, the other alternate interior angle pair, those are both obtuse. So those are the same. So our first warm-up one, we have parallel lines imply alternate interior angles are supplementary. Well, if we looked at the 4 and 5, and then individually the 3 and 6, each of those pairs are the same type of angle, either acute or obtuse. So this would be a false, and we would want it to be parallel lines imply alternate interior angles are congruent. And it doesn't matter if you put the congruent right after the arrow or at the end. And let me fix my parallel line symbol is a little not great there. So our parallel line symbol is basically 2 vertical lines next to each other. So the next one we have parallel lines imply corresponding angles congruent. Now that one is going to be true because if you look at 1 and 5, both obtuse. 2 and 6, both acute. Same idea for 3 and 7, 4 and 8. So when it's the same type for each, they are going to be congruent. Now if we look over to our green card, we do see that there. So we got parallel lines implies congruent alternate interior angles, and parallel lines implies congruent corresponding angles. Notice each of those have a double arrow on them. And because of that double arrow, we could actually use them in either direction. Today, we will use it working left to right. Later on, we will use it working right to left. So today, we're going to be given parallel lines, and we will then be able to conclude that we either have congruent alternate interior angles or congruent corresponding angles. All right, you can stick your warm-up sheets away. Moving over to our homework, which I believe was on page 10. The first given is just telling us that that's all a straight line, which will allow us to do our linear pair applies supplementary angles. Sometimes they'll give that to you, sometimes they'll just expect you to pick it out from the picture that it's a straight line. So anyway, we can say 1 and 2 are supplementary, and then separately 3 and 4 are supplementary. That's one of our new reasons from day 2, the linear pair implies supplementary angles. And then that will always be followed by congruent angles implies congruent supplements. So the congruent angles means those angles outside the triangle. implies that their supplements, the ones inside the triangle, have to be congruent. So we'll have angle 2 congruent to angle 3 as our statement. And if we go to the second one, we've got our givens. We should be curious as to why they gave us angle 1 congruent to angle 2 when they're outside of the triangles. Well, they have angles on a line next to them inside the triangle. That's what would lead us to know to do our linear pair sequence. So we've got our linear pair implies supplementary angles. I chose to number those inside ones 5 and 6 because they were the first numbers we hadn't used yet. So in my picture, I have angle 1 and angle 5 are supplementary, angle 2 and angle 6 are supplementary. Depending how you named yours in your picture, it could be slightly different numbers. And then automatically after that, we follow with congruent angles implies congruent supplements. That would give us our angles inside the triangles now congruent, angle 5 congruent to angle 6. We had an angle from 3 and 4 in the givens. We have an angle now from 5 and 6. We still need a side, but we can easily get a CF congruent to CF by reflexive property. And now in our triangles, you have two angles here. The side is not in between those two angles, so this is angle, angle, side, congruent to angle, angle, side. All right, we're going to be starting on page 12 in the packet. Now notice it says BRM there, but we're not going to be doing the basic rigid motions this unit because we already did a whole bunch of them last unit, and it's all pretty similar, those basic rigid motions. So again, we won't be doing the basic rigid motions that's listed there. So you can just ignore those. I can't remember if it's on the homework ones or not, but you can just ignore them. So we'll go ahead and do our statements, reasons, and givens. From our givens, we have one set of congruent things. So let's put our tick marks on B, C, and DC, and we'll put an S next to there. Because notice our proof is we just want to get those two triangles congruent, so we want to get sides and angles congruent. Now we have a set of parallel. We mark parallel with a little arrowhead on each of them. If we had a second set of parallel segments, we would do double arrowheads on those. Now note, those arrowheads do not mean they're congruent, and therefore do not give us a side or angle in our proof, but it's just to show that they're parallel. Now, our two new reasons, we've got parallel lines implies congruent alternate interior angles. Always look for that one first because of the parallel line ones, that happens way more than the other one. The second one is parallel lines implies congruent corresponding angles. For alternate interior angles, we want to think our zigzag. So the zigzag needs to include the parallel lines. So here's one way we could do our zigzag. So one pair of alternate interior angles could be angle A and E, or we could have done our zigzag going this way, and our angles that are alternate interior could have been B and D. So we're actually going to get two sets that we could use. So first off, our reason is going to be parallel lines implies congruent alternate interior angles. And then we can do both sets of those alternate interior angles in the same step. We can do that angle A congruent to angle E that we saw first. And we can also do angle B congruent to angle D that we saw second. I'll mark one of those sets up with a single arc, the other set with a double arc. And I'm going to put an A and another A here because we got two sets of angles from that step. So we should have enough to get the triangles congruent. Now when we're looking at our markings in the picture, we're looking not at the parallel marking. We're looking at the side that has the tick mark when we're looking at sides. So we definitely have two angles, and then that tick mark is not in between the two angles. So this would give us angle, angle, side congruent to angle, angle, side. And our statement is just our triangle ABC congruent to triangle EDC. So our new stuff for today is the two parallel line reasons on our study card. So make sure, in addition to doing your homework proofs tonight, that you study those until you have them memorized. Each of the days in this unit, we will add one or two new reasons, and then as we add those on, we'll want to make sure that we study those until we have them down. Moving on to number 2, go ahead, do your statements, reasons, and givens. So we had two sets of things congruent, AB congruent to BC, I'll put one tick mark on those, and then we've got BD congruent to AE, and I'll put an S next to each of those. Our other given we have is parallel. So let's look first to see if we have congruent alternate interior angles. I'm going to mark my parallel lines up with the arrowhead. So here's BD and AE. We'll put an arrowhead on each of those. So when we try to do our zigzag, we want to do our zigzag including those parallel lines. So our zigzag in this case would look like this. But when we do that zigzag, one of the angles of the zigzag is in the triangle, but the other angle is not. So this would signify that this is not a case where we would be doing parallel lines implies congruent alternate interior angles. So therefore, we want to look for parallel lines implies congruent corresponding angles. Remember our basic parallel line picture, and the corresponding angles are either top left and top left, or you could have top right and top right, or you could have bottom left and bottom left, or you could have bottom right and bottom right. So any of those pairs would be considered corresponding angles. So I think it's helpful to identify the corresponding angles by extending some of the sides. So let's extend these sides here. And notice that this angle right here would be in the top right. We'll extend our parallel line up above, and this angle is now in the top right. So to make those easier to work with, I'm going to go ahead and number 1 and 2. In our next step, we're going to do parallel lines. It implies congruent corresponding angles. And our statement is we'll just have angle 1 congruent to angle 2. I'll put an arc on each of those, and that gives us an A. Now, just because it says SSA over on the left does not mean it's SSA in the picture. We got to look in the picture and see. We have two sides, and that green angle is right in between the two sides. So this is, in fact, side angle side, which is one that works. And our statement is just what we want to prove. Triangle BCD is congruent to triangle ABE. All right, going over to number 3, we'll do our statements, reasons, and givens. Now, one thing I forgot to mention on proof 1 is we did 2 sets of congruent alternate interior angles. You did have the option to do just one set of those congruent alternate interior angles in step 3, and then you could have also done a vertical angles implies congruent angles to get a second angle. Depending which set of alternate interior angles you used, you would have had either angle, angle, side, or angle, side, angle if you decided to do that. Now, I chose to show you this way because it's actually one less step if you just do both of the sets of congruent alternate interior angles. But again, we could have just done one and done a set of vertical angles as well. Okay, so going back to this proof, let's have you start with given number 2. So given number 2 is from last unit. And see if you can take given number 2 as far as you can go to get things congruent. We're going to pause the video for 2 minutes for you to take that given as far as you can. All right, so we should have segment bisector implies midpoint because BE is what comes after the word bisects. We'll have C as the midpoint of BE. Then midpoint implies 2 congruent segments, so BC congruent to CE. We said it's congruent in our proof, so let's mark it up in our picture, and that gives us a side. Well, next we have our parallel lines. So first check for a zigzag, and I've never put the let me maybe put those in first. Here's our arrowheads for the parallel lines. So when you do your zigzag, it needs to involve those parallel lines. So you could do a zigzag that way and get angle B congruent to angle E. Or you could do a zigzag this way and get angle A congruent to angle D. And the reason we know those are the angles is because those are the angles of the zigzag. That's how you help identify where your alternate interior angles are. So we actually need 2 angles, so let's do both of them. So we'll do our parallel lines, implies congruent alternate interior angles. We'll have angle B congruent to angle E, and we'll have angle A congruent to angle D. We'll mark those up in our picture, one of them with 1 arc, the other with 2 arcs. And that gives us 2 sets of angles. Now when we pick out our markings, that parallel line marking the arrowhead doesn't count. That wasn't something congruent. So I purposely did them in different colors here. So we got the 2 blue angle markings, and then the blue tick mark for the side marking is not in between the 2 angle markings. So this would be an angle side case. And our statement is just what we wanted to prove. Triangle ABC is congruent to triangle DEC. And remember, we're skipping the basic rigid motions in this unit. We did a bunch of them last unit, so the hope would be that you are still good with those. All right, going over to number 4. We'll do our statements, reasons, and givens. We have one set of things congruent, so we'll mark that in our picture, AD congruent to BC. We have a set of parallel things, so BC and AD are parallel. So we'll put our little arrowhead on for those. And I'll also put an S next to that AD and CB, because now we got a side. Well, based on our parallel, if we do a zigzag that involves the parallel lines, this is the only zigzag that involves the parallel lines. So those angles of the zigzag, I'm going to number them to make it easier to work with. So I'm going to number them 1 and 2. And we'll do our parallel lines. Implies congruent, alternate, interior angles. And our statement will be angle 1 congruent to angle 2. I'm going to put our arcs in, and we'll put an A here. Well, we only have 2 things, so as always, when we're short, we look for vertical angles with our crisscrossing lines, which we do not have here, and we look for reflexive property when something is shared, which we do have here. So we'll do reflexive property. Which will be BD congruent to BD. We'll mark that up with an X in the picture, and that just gave us a side. Just because it says SAS over on the left there doesn't mean it necessarily is in our picture, so we have to check and be certain. So our 2 sides that we had marked up, then there's an angle that is in between, so this does check out as a side angle side, which works. And our statement is just what we wanted to prove. Now, in these proofs we've seen so far today, it's just been getting the triangles congruent. We could see parallel line proofs where the proof is like 2 sets of angles or 2 sets of sides congruent to each other. And then we would just go 1 step beyond the congruent triangles, just like we did on day 1 of the unit, where we did congruent triangles implies congruent corresponding parts to finish out the proof. All right, one last one we're going to look at over on page 14, number 5. Go ahead, do your statements, reasons, and givens. Now we do have several triangles in our picture. So let's take a moment to identify which ones we're trying to get congruent. We want ABE, which is this triangle, and DCE, which is that triangle. We've got to start out some parallel lines. So I'm going to put a little arrowhead on BC, and I'll put a little arrowhead on AED. We have some angles congruent. We've got EBC. So EBC would be this one here. B is the middle letter. ECB would be this angle here. Now, even though we marked some angles up congruent, I'm not going to put an A next to step 2 because those are not angles that are in our triangles we're trying to get congruent. Now, they were very generous in our proof here. They told us BE is congruent to CE, so we'll put our tick mark on those and we'll put an S here because that is a side in our triangles. Now, the reason I say they were very generous in this proof is they didn't have to tell us that because those two angles we marked are congruent base angles in that middle triangle. So we could have done two congruent base angles implies isosceles triangle for BCE being isosceles, and then isosceles triangle implies two congruent sides to get BE congruent to CE. So we could have gotten what they told us in given number 3 with our isosceles triangle stuff, but it's nice they gave it to us. It saves us some steps. And then we've got a midpoint. So we're going to have to work with our midpoint reason and also one of our parallel line reasons. Let's maybe go ahead and we'll start with the midpoint reason. So we got midpoint implies two congruent segments. Hopefully at this point we could do that reason in our sleep. E is right in the middle of A and D, so we're going to have AE congruent to ED. We'll mark it up in our picture with a different number of tick marks, and that's a side. All right, now our parallel lines, always look for the zigzag first for alternate interior. So if we start with the top parallel line, we could do our zigzag going this way, and that could give us one of our congruent angles congruent to that one down there. Or we could do, involving our parallel lines, do the zigzag going that way. And that would give one of our congruent angles congruent to that bottom angle. So let's do both of those. So I'm going to number this bottom angle, angle 1, and this bottom angle, angle 2. And we're eventually going to get two sets of congruent alternate interior angles. So we'll do our new reason for today. Parallel lines implies congruent alternate interior angles. Now make sure you put that congruent after the arrow. On tests, I sometimes see people will forget that congruent, and then that's useless. We don't want just alternate interior angles. We want to know that those alternate interior angles are congruent to one another. So I'm going to put, and watch carefully how I mark this up. I'm going to put two arcs on this angle and two arcs on this angle. So that's angle EBC congruent to angle 1. Comma, and then the other one's going to be angle ECB, our other congruent one we had before, congruent to angle 2. When I go up to my picture, I'm going to mark those two with 3 arcs. And notice when I put the 3 arcs in, I didn't use that first arc as one of the 3. I'm not going to put any A's next to that step in my proof because of the 2 blue, only one of them was in our congruent triangles. Of the 2 red, only one of them was in our congruent triangles. So that doesn't count as a set of angles congruent in our triangles yet. But what we want to recognize from our markings is we've got some angles that were marked up in 2 different ways. When we see that visual, that should lead us to know we want to do transitive property. So we'll do that next. And I want us to focus on step 2 and step 6 in the proof. We have in the black step, EBC is congruent to angle 1. In step 2 up above, EBC is congruent to ECB. So the conclusion we could make is that angle 1 is congruent to angle ECB. We basically use this and this here. Well, that's great, but angle 1 is still in one of our triangles we're trying to get congruent, but ECB is not. So now we can use our statement in 7 and the second part of the statement in 6. So let's do another transitive property. So they both have ECB in it, so we'll now just have angle 1 congruent to angle 2. Transitive property is the one thing that you can't just group a whole bunch of them together. If you're going to have multiple transitives, you got to do it separate. So I'm just going to make angle 1 have the red arcs now so that they show that they're the same. That was A. Just because it says SSA on the left does not mean it's SSA in our picture, because if it was, we would still need more. If we look at our picture, we've got those purple tick marks and then the red angles right in between. So this would be side angle side, which is one that works. And then our statement is just what we wanted to prove. Triangle ABE is congruent to triangle DCE. All right, so any time left in the period, you can either work on your homework or you can work on your problem set. Have a great rest of your day.